Good afternoon to everyone. Today's concept is classifications of circuits arrangement. Classifications of circuits arrangements. Classifications of circuit arrangements. Normally, there are two ways we used to classify, we used to arrange the circuits. One is series circuits. One is series circuits. Another one is parallel circuits. Another one is parallel circuits. So this is series circuits and this is parallel circuits. Now what is meant by series circuits and what is meant by parallel circuits? This is one by one we are going to be discuss. Series circuits means the circuit in which the resistances are connected one end to the another end, so that there is only one path of current flows is called series circuit. Series circuits means the circuit in which the resistances are connected one end to the another end, so that there is only one path of the current flows. Then we used to call it is series circuits. So series circuits means the resistances normally. So we will discuss the first one, series circuits. Series circuits means the resistances are connected from one end to the another end, so that only one path of current flows is normally we used to call it is series circuits. So this is the polarity plus and minus we have given. This is the total current IT. This is the total current, and these are all the resistances R1, R2, R3. Okay. Now for this series circuits we are having the three important properties. This you should not forget. The first one is we can say characteristics or properties. We can say the characteristics of series circuits. What are the characteristics of series circuit? The first one is I is same, nothing but the current is same. The second important thing is voltage will be changes. The third one is number of voltage drops is equal to the applied voltage. Number of voltage drop is equal to the applied voltage, nothing but total voltage, applied voltage. These three important properties you should not be forget. The first one is voltage, current is same. The second one is voltage will be drop. The third one is the number of voltage drop is equal to the applied voltage. Let us say we have taken one simple resistive circuits. Here the resistances we have connected from one end to the another end, thereby only one path of the current will flows. I told you whenever the current will flows through the resistance, then there is a voltage drop. V1. Whenever the current will flows through the resistance, again there is a voltage drop. Whenever the current will flows through the resistance R3, there is a voltage drop. Okay. So voltage will be changes. What is the current flowing through the resistance R1? What is the voltage drop across the resistance R1? V1. What is the voltage drop across resistance R2? V2. What is the voltage drop across resistance R3? V3. Okay. So now the third important one is number of voltage drop is applied is equal to the number of voltage drop is equal to the applied voltage. So V is equal to, this is the total voltage, V is equal to V1 plus V2 plus V3. We know that normally V is equal to I into R. So now V is nothing but I into R equivalent. What is the voltage drop across resistance R1? V1. What is V1? V1 is nothing but what? V1 is nothing but I into R1, because total current flowing is I. So you can represent the small I or you can represent the capital I, anything. So I into R1 plus What is the what is the voltage drop across resistor R2? V2. V2 means I into R2. I into R2 plus V3 means I into R3. So I into R equivalent is equal to I. If you take out the common I, R1 plus R2 plus R3. So I and I will be gets cancelled. R equivalent is equal to R1 plus R2 plus R3. If there are n number of resistances are connected, then R1 plus R2 plus so on Rn. So on Rn. So so always when the resistances are connected in series, you must be add. Just close your eyes and just you need to be add the resistances. Let us say for example, if I am having 10 ohm and if you are having 20 ohm, so if you are connected the voltage across this circuit, okay, I. So what we need to do in order to find out the equivalent resistance, so we need to be write 10 plus 20 is 30 ohm, and thereby you are having the voltage V will be like this. Voltage V will be like this. So this is how you need to be do the performance whenever the resistances are connected in series. Just you need to be add. Next thing is inductance. Let us say I need to be find whenever the inductances are connected in series, what we need to do, whether we need to add or whether we need to be subtract, what we need to be do. Let us say we will discuss. So we are having one inductance will be like this, another inductance will be like this. So we have connected an alternating an alternating voltage V will be like this. Okay, so we are having L1 and we are having L2. Ultimately, the total current will be I. So whenever there is a passive element, there is a voltage drop. So this is VL1, and ultimately we are having VL2. What is the voltage drop across inductance L1? VL1. Voltage drop across L2, VL2. The total voltage is the total voltage will be V. So V is equal to VL1 plus VL2. V is equal to VL1 plus VL2. We know that one voltage across the inductance VL is equal to L into Di divided by dt. L into Di divided by dt. So L equivalent Di divided by dt is equal to what is VL1? VL1 is nothing but L1 into Di divided by dt, because only one path of current will flow from one end to the another end, plus L2 into Di divided by dt. So Di divided by dt, if you take them out, then L1 plus L2, so L equivalent into Di divided by dt. So this and this will get cancelled. L equivalent is equal to L1 plus L2. That means whenever the inductances are connected in series, ultimately what we need to do, you need to just add. So we have connected an alternating voltage source here, so ultimately the current will flows, and there is a voltage across the voltage across the inductance L1 is VL1, voltage across the inductance L2 is VL2. So total voltage, number of voltage applied is V is equal to VL1 plus VL2. So we know that one, what is voltage across the inductance? L into Di divided by dt. So L equivalent. So you can able to find out the equivalent of the inductance. Whenever the inductances are connected in series, you just add. You need to be add. Next important thing is capacitance. What capacitance will do? Capacitance. When the capacitances are connected in series, ultimately what is going to happen? No doubt, current will flows. This is C1, this is C2. So voltage across the capacitance VC1 and voltage across the capacitance C2 will be the VC2. What is voltage across the capacitance C1? VC1. What is voltage drop across the C2? VC2. So the number of voltage drop is equal to the applied voltage. So V is equal to VC1 plus VC2. VC1 plus VC2. What is V? Voltage across the capacitance. Find out how we need to find out voltage across the capacitance. Voltage drop across the capacitance, we need to be find out 1 by C integral of I into dt. This is what the formula. what is the voltage drop across the capacitance, or what is the voltage across the capacitance. V is equal to 1 by C integral of I into dt. So we can able to write here 1 by C equivalent integral of I into dt is equal to 1 by C1 integral of I into dt plus 1 by C2 integral of I into dt. So you can able to take out 1 by C1 plus 1 by C2 integral of I into dt. So this is 1 by C equivalent integral of I into dt. This will be get cancelled. 1 by C equivalent is equal to 1 by C1 plus 1 divided by C2. Still you can able to simplify this. You can able to find out C equivalent C1 C2 divided by C1 plus C2, C1 plus C2. So therefore, whenever the two capacitances are connected in series, so equivalent capacitance will be C1 C2 divided by C1 plus C2. Thank you for watching this video.